So, can I ask you one quick question since I just figured this out on my calculator?
What?
Another problem?
What?
How come when me and him are typing it in, we're only getting 1.29? I know it's only a rounding issue, but is the book giving you the 1.3?
Are you punching in those numbers?
Yeah.
Yeah.
We're getting 1.29.
1 point.
Punching in those numbers?
Yeah.
Yeah, I got 1.29 also.
Really?
Yeah. I mean, I know it's not that much. I don't know if you were using the book's answer, like, or.
No, I thought I punched it in. I'll have to, later on, when we get through this, I'll go back and get my calculator and punch it in, but I thought pretty sure that I punched it in like that.
Was it 1.3 before you changed it, what you just changed?
It was 1.34 before I changed the 48.2. This was the only thing I changed right here. This I had 50, and I
Okay.
changed it to 48.2, which in the overall scheme of things shouldn't make that much of a difference. But I'll have to go back
I
and,
mean, it's not a huge difference, 1.29.
no, and
0.04 still.
what I would say is if you come up with 1.29 and mine's 1.33, if I go back here and look at these numbers and they're all the same,
Yeah.
then we're good.
Okay, I just wanted to make sure.
Yeah.
that-
I don't know why, but if you punched in those numbers just like that and I punched them in just like that, they should come out to 1.29.
Yeah. Okay.
So I'll have to go back and get my calculator. And if it does come out to 1.29, then I will update my sheet again, for that matter.
I got the 1.29, but I had slightly different numbers for my distance. Like I had 228
Oh, maybe I looked at it wrong.
instead of 220.21, and I have 48.55 instead of 48.2.
You had 228?
I had 222.8.
Oh. Yeah, well, based on my numbers that I wrote down there, I'll have to go back and look at it, but, and that would be rounding
Right.
at a certain point. So I'll go back and look at those, and we'll go from there. Now, on to 820, again, if you write the numbers, you show your work, it won't make any difference. Okay, so 824. So that refers back to that kind of that oblong shape that looks something like this, where I had split it out into the two half rounds and the square piece, right? Yeah, it wasn't square, it was rectangle. So, and I called this part number 1, this number 3, and this number 2. I don't know why. Usually you'd start over on the left side with 2 and then go to 3, but I didn't. It doesn't much matter. So the moment of inertia for X, that's the moment of inertia for the whole thing, right? Because we had figured that out in problem 8 and 9. So that value was 627.67 inches to the fourth. I didn't really see any need to go back and redo that since I had already done it in my homework. And I think I already go over these in class? So I don't really see any need to do that again. Okay. Let's see. Then I need to go back and do, well, actually I did go over that. That ends up being that value, if you will. The way I calculated that is the base times the height cubed divided by 12. That's the rectangular piece, right? Plus pi times the diameter raised to the fourth power, not cubed, divided by 64. Do what? This represents both of those half rounds.
So you use the formula for the full circle instead
Uh-huh.
of doing it twice for the semicircle. Yes. That's true.
You use the full circle formula. Then it looks like half circle.
Which is exactly the same, isn't it? For the X direction. I couldn't do that for the Y though, could I? Because the Y, there's a distance between them. So for the y, you would have a distance from this center of gravity of this one to the center of gravity of the total thing. So you couldn't do that. You'd have to have a times d squared for each one of those segments if you were doing the y value. In fact, well, we have to do that because this is polar moment of inertia, right? This is a polar moment of inertia problem, and we have to do the x and the y. So I told you all along, you can get by without the y. Well, you can't always, can you? It's a lesson to be learned there. Sometimes we're sneaky. Okay, so that's how I figured out this x value. Okay, but you could also go back and look at your 8, 9 and have looked there as well. But you can, in the case of the x, because there is no d value, right? There's no distance between the center of gravity with respect to the y-axis difference than there is for the center of gravity here. So there's no difference in the height of that. There is a difference in the if you will, the length of that d value when we do the y, IY.
Why is 4 inch here?
Do what?
You cannot say 4 inch. Y value, the distance between center to top is 4 inch.
The y value for all three of them is 4, isn't it? So if we listed y1, the value would be 4, right? y2, the value would be 4. y3, the value would be 4. So if you had a d value, it would be 4 minus 4, right? In all three cases. So you have 0. So there's no need to do the moment of inertia of each one plus the area times d squared, because area times d squared is 0. So then we just do that. Now on the y value, what we're looking at here now is we're going to have this one right here, and then we have this here, and then we have this here. Now again, they're exaggerated right now, but if we're looking at the x bar, the x bar is measured with respect to the y-axis, isn't it? Well, the center of gravity is going to be right down through here. This is going to be y, isn't it? But there's a y value here and a y value, or an x value there and there too, isn't there? So we're going to have to figure out this. This is going to be a x bar minus x, isn't it? And there's going to be an x bar minus x here, which will then be our d in the x direction, if you will. Okay, so that's where we have to play that way now. So we do have a little bit of difference here. So we can do x1. That's going to be what? And again, that's let's see. Yeah, I cheated on that, didn't I? Well, x1's going to be right in the center. So this is getting kind of sticky. I really don't need to worry about that particular x value, because d1 is going to be 0, isn't it? Because it's right through the center. The distance I have to worry about is this x bar minus x for 2 and 3. So how do I calculate this value right here? According to your chart, where is it? I didn't show it, or did I? Yeah, I did. Yeah. That distance right there, the x for each of those individual pieces, if you look in all your charts, this distance right here is going to be 4 times the radius, divided by 3 pi. There's probably some 0.10 something or other there times the radius. 0.425. So that ends up being 1.68 inches. Oh, excuse me, millimeters. Sorry. So that's the distance from the flat out to the center of gravity, right? But that's turned on its side here, right? So then we have to go and go half of this base, which is 5, right? So D2 equals D3 equals 5 inches, again, which is half of the base. A different base, huh? Not base, like really low. Okay. Plus 1.68. So that's 6.68 millimeters. Okay? So we have to have that number. Does that make sense? What we're doing there? Again, because we're working from the y axis now. The x axis, it was all going right through the same axis. All three of those points were. So now then, we have to do the IY for each of the individual pieces. So the IY for 1 is the height, which is 8 times 10 cubed divided by 12. Right? That's the y moment of inertia for a rectangle. We just flip those, don't we? The base and the height. That value turns out to be 666.67 millimeters to the fourth. The moment of inertia about the y-axis for 2, 3, if you will, they're both the same, is going to be what? 2 times, let's see, the moment of inertia for the half, if you will, for the half round is 0.1098. That's right in your charts that you've got in your book, bless you. Times the radius, which is 4 raised to the 4th power, plus the area, which was 25.1, times D, which was 6.68, and that value has to be squared, doesn't it? And let's do this. Let's make this a bracket and then a bracket. Okay, so that whole number right there times 2, and that equals 2,310. Oh, I put inches. Did I go from, is this supposed to be inches or millimeters? Huh? This one's inches, isn't it?
Yeah.
Okay, I gotta go back up here and fix this then. I started to write inches and you let me talk myself out of it.
There's also millimeters up top on the IX.
Yeah, see, I got two problems running together. So let's do this. Let's put a big old fat line through there. So as not to get those mixed up. Inches. Inches to the 4th, and that's inches to the 4th. Okay. Then to get the y value for the whole system, we take, and I've got, okay, I was looking at something. Okay. 666.67. Have to get that 7 in there. plus 2310. The 2 times is because I've got 2 sides there, right? So that's the total of 2 and 3. And that equals 2976.67 inches to the 4th. That's Y bar, okay? Total Y bar. To find your polar moment of inertia, you add that plus the X bar, or excuse me, the moment of inertia about the X axis. 627.67 inches to the 4th plus 2976.67 inches to the 4th equals 3603.67 inches to the 4th. The hardest part's finding the moment of inertia about the X and the Y. Then the polar moment of inertia is a piece of cake, isn't it? I can tell you this. You will have to calculate the polar moment of inertia for your test problem. One problem.
The whole test is only one problem?
Mm-hmm.
It's not gonna be a shape that looks like that, is it?
Mm-mm.
That shape sucks.
Even if it was, I wouldn't tell you. That shape sucked.
Hate it.
Huh?
That'll be a good problem.
It makes you think a little. And that's something you've got to do. The first one, the thing that bothered me the most was remembering to flip that and use the Y value instead of the X. That was, once I got past that, then the problem was easy, but that was the hardest part. And I will apologize, I didn't necessarily mean for you to do extra work, but 824B would require that you did extra work. If I'd have done A and D on the first go round, then we could have used those. But then again, it forced you to do a little bit of something different. Because the next one was 824, was it B? I think it said to do A and B on,
Yeah, I started doing D.
or it said to do the shape for B, right? For
Yeah,
8, 9.
We were doing B last time we did A and D.
yeah. So it's a little bit different this time. Any other questions on this one? Clear as mud, right?
What that D also represents,
What's the D what?
D of
That's 0 here?
D of.
This one? D1? Oh, here?
Yeah, what that represents.
It should go away. I think what that was, Harihara's, I was talking about this X bar minus X was the D value for that. So, but that's what we're dealing with. That's where these D2 and D3 came from. It's 5 inches from the center to this edge, and then another 1.68.
That is D of.
Do what?
D of is X bar minus X.
X bar minus X, that's D2 and D3. Yeah. So, you could have said that equals D3 and that equals D2. Okay? That's kind of what we did there. Anything else? Sure. Love to.
I did D.
You did.